Hi, welcome to the very first session of the Ben and Chris show. We're going to be teaching you Python over the next few weeks. So my name is Chris Hedlians. I'm the Schools Director of Teaching and Learning at Computer Science at the University of Lincoln. I'm here with my colleague Ben.
Hi, my name is Benjamin Williams. I am a research assistant and PhD student at the School of Computer Science in the University of Lincoln.
So throughout the next few weeks, we're going to be taking you from writing your very first line of code all the way through to producing your first program. So we'll be doing this in the programming language Python for a few reasons. So Python is a really useful language. It's really versatile. You can extend it loads of ways, and that's one of the reasons why it's one of the most popular languages to learn on, because once you know Python, there's a whole range of jobs that you can do with it. But it's a really great one to learn, right, Ben?
Yeah, so Python's a great language. As Chris said, it's quite easy to learn. That's why it's kind of favored by A-levels, secondary schools for A-level courses and this kind of stuff. But aside from that, it's a really powerful language. I think a lot of people overlook and kind of disregard Python, but it's a very, very popular language. It's very powerful as well. And also, it's great for things like career opportunities. If you're going for a particular type of job, even if you're not in the field of computer science, sometimes it's good to have that in your kind of like a feather in your cap, So, and plus, programming is really fun. The reason I got into programming was just because it's really fun. So
it's really fun until you end up having to debug lots of lines of code. I mean, one of the things that we want to kind of highlight with this is Python isn't a beginner's language. It is, if there is such a thing, Python is a fully used, versatile programming language that is used all over the sector, everywhere from social media to data analysis to games development to animation. Python is really it's a core language that's used in so many areas. So a lot through my PhD and my research, I was using Python code on really high performance supercomputers. But we also use Python in our first year modules at Lincoln to teach basic programming. And that's really where we're going to be starting with this. So we're going to try today to kind of really introduce you to what Python is, how it looks like, and also the Replit platform, which is what we're going to get used programming. Now, if you've got two monitors, you might want to code along with us, or if you can kind of fit the broadcast and Replit window on the same screen, you can have a go at that. But don't worry, we're going to record these sessions. They're all going to go up on YouTube. So if you can't follow along with us now, you'll be able to at another point. The important thing really is to listen to what we're going through and hopefully try and take something away from it. If anybody has any questions at any point, post them into the chat. Just noticed Will's just posted in and said, that is a very colourful background, Chris. Well, it's Christmas, so 'tis the season to be jolly. So, right, Ben, I'm going to hand over to you and we'll go into Replit.
Brilliant, yeah. So, yeah, the first thing we want to do is talk about this Replit tool. So there's a few ways of writing Python. You can either download the software from the Python website and then run the Python kind of editors and all this kind of stuff on your desktop computer. The reason we're using Replit is just because we can get right into the code without having to worry about all that kind of installation and setup. It's one of the first things that actually puts people off writing code, is because it's so hard to go from not writing code to writing code. So yeah, that's what we're going to use. So to find this, you just go to Google. Just like, oh, not this. And you just type in Replit like this. Okay, so it's REPL. If I do it in capitals like that, right? So you just type that in, just hit enter or press search. And then it's this first link here. So REPL.it, right? The collaborative browser-based IDE. And this is what it is. You don't have to download Python and install all kinds of stuff. You can just get on with writing code. So what you do is just click this link, and it'll bring you to this page. There's a bunch of stuff down here. But the one button you should focus on here is this Start Coding button, right? So if you click this, it'll take you to a kind of sign-in page, as you see here. And you can sign in with Google, GitHub, Facebook. I think you can even make your own account. For this, I'm just going to click GitHub, so I'm going to sign in. And as you can see, it brings me to this this dashboard. Now, the cool thing about this replit site is you don't just have to write Python. I know we're going to be writing Python. That's all we're going to be focusing on. But there's a bunch of other stuff you can do. You can write in any language. So you can either click Python here, or if it doesn't show here for you, just click all languages, and Python should be here under popular. So just go ahead and click that.
There is a question in the chat, Ben.
Yes.
So from MJ says, is this for people completely new to Python? So yes, we're going to start right at the beginning, but we're going to take you all the way through to writing a program in Python. So yeah, if you're absolutely completely new to Python, just watch from the beginning. You'll be absolutely fine. If you've done a bit before, you might find going through the basics useful, and that's what we're going to start from here. But we will get more complicated as the episodes carry
on. Yeah, so as Chris said, this is from the very beginning. We're hopefully going to give you a very, very gentle introduction to Python. So, yeah, the first thing I want to talk about before we actually get into writing code itself, I want to talk about this interface. So here on the left, you've got like files, and you don't have to worry too much about this or this bar up here. One thing we are going to focus on, though, is these panels here. So this one here, this is where you write your code. It's called the editor. And then here on the right, we've got the output window. And this is what they're called. So you write your code in here, and you press run, this run button up here, and it will do something, or the output of the program will be here. So that's all we have to be familiar with. We're not focused on code right now. We just need to know that this is where you write code. You write it in here. You could write whatever you want in here. And then you click run, and then the output is displayed over here, where it says Python 3.82, all this kind of stuff. It will be displayed here. And that's all we need to know for now. We don't need to know any of these buttons or what they do, or any of this kind of stuff on the left, all these files and stuff. Don't worry about that. If you've got Replit open, if you hear me talk about the editor, what I mean is this bit here where we actually write code. This stuff on the right.
So you can think about this as it's a bit like I suppose a Google Doc, isn't it? It's kind of an online platform where you can type in content.
Yeah. Essentially, that's what it is, right? And the content you type in here, you click run, and it will produce some output here on the right. And that's what we're going to be focusing on. Just these. And I just the only reason I wanted to talk about that is because we don't have to worry about all this stuff. I don't want to overcomplicate this kind of stuff. So before I actually again get into writing code, I suppose we have to talk a bit about what computers are, right? So computers are very good at performing instructions, very good at performing things that we tell them to do, right? So if they weren't so good at doing instructions that we tell them to do, it might be a problem, right? Computers.
Nobody wants a computer with an attitude problem, right?
Yeah, like you tell the computer, hey, go off and do this thing, and it went, no, I'm all right. It doesn't work like that. Computers will always, if you tell them to go off and delete a file, it will, there's exceptions like the file.
My experience often isn't that.
Yeah. So there might be exceptions like when the file is in use or something like that. But the idea is that computers run instructions for us. They don't have free will, right? If they did have free will, we'd have a very big problem on hands. So what computers are really is they just perform instructions that we give them. And the question is, how do we communicate those instructions to a computer? Well, the way we can communicate instructions from me to you is maybe I could write out a list of instructions like a recipe, for example. I like using this analogy of a recipe because it's very similar to, weirdly, how code and software runs. You can think of a recipe as a set of instructions, right? Maybe you've got a recipe for I don't know, making a cup of tea, right? Or baking a cake. So maybe the beginning of that recipe, step one is go off, find the eggs, find the butter, put them into a bowl or something. Step two, mix them up, right? Step three, I don't know, put them in.
You've not baked many cakes before, have you, Ben?
No, you can probably tell. But yeah, the idea of a recipe is we start at step 1 and we go to, once we finish step 1, we go on to step 2. Then we go on to step 3 once we've done with step 2 and so forth. And we do each one of those things one by one. And at the end of that recipe, we'll have a cake. Hopefully we should have a cake.
And the important thing is as much in the process and the order as well, right? Because you're not going to be putting your bowl in the oven before you've got your eggs out the fridge.
yeah, exactly. I mean, this is so this is what we usually call sequence, like a sequence of instructions or a sequence of statements, right? Where, like Chris said, if we've got a recipe for, I don't know, I'll go back to making a cup of tea, right? So say our recipe for making a cup of tea is get the cup out of the cupboard, put it down, put the tea bag in, then hot water, and so forth. What if we, or change the order of those steps? So we do the boiling water first, and then take the cup out of the cupboard next, right? That doesn't make any sense, because we'd end up just pouring boiling water all over the kitchen floor, right? So the order of those instructions matters, and that's one thing we've got to take into consideration. So computers, like I said, they're very good at performing instructions. Very good at, like, if we give it a recipe, it will do each step, one by one until it reaches the end. This is all computers are, really. They're just big calculators. We just give them a bunch of instructions, a set of instructions, and they go through them one by one, and they do them, right?
So I mean, let's give an example of that, right? Let's try a first print statement.
Yeah. So the most basic program you can write is, or well, one of the most basic programs you write is just to write something to the console, right? So what I mean by console is this thing over here, the output window. So if we just write print, okay, and we put something like this in here, I'll get into the syntax and why this matters in a moment. But all this will do is it will just write the word hello out here, okay, and that's a very basic example. But as I was talking about, instructions, the way we can communicate those instructions with the computer is through code, right? This is what code is. This is what programming is. It's kind of telling a computer how to do things. It's our way of describing a set of instructions to a computer. Here we have a very basic program, right? We could put whatever we want in here, so it doesn't have to be hello. We could put something, or my first program or something. We could put whatever we want in here, and that's what this is. This thing here. So I'll go over the syntax a bit. This thing here is called the print function, and you might think, why is it called print? It might be a bit confusing because you think of print as in a
kind of sending something out to a printer, right? Yeah. Actually turning it into physical copy.
Yeah. In this case, it just means write. You can almost imagine this as write. Write this thing here to the thing on the right here, this console. And this is all it's doing. This program consists of one instruction. Yeah, right? And all it's saying is just write this, my first program, to the output. That's all it is. It's a program with one instruction. That's all it is. The question is, can we make ones with more than one instruction? Well, yeah, we can. We can give it another instruction and say hello. So now there's two instructions. It says write this, my first program, and then once you've done this, write this thing. So what it's going to do is if we press run, is we get this, my first program, hello. So hopefully that all makes sense so far.
I think one thing, going back to this kind of sequence, it doesn't matter how many times you run that, my first program will be printed to the console first. And the second line, hello, will definitely be printed second, right? No matter how many times you do that, that order is going to be consistent.
Yeah, exactly, right. If I press run as many times as I can, look, it will always show hello second. And this is what I meant by, computers just go off and do exactly as we tell them. because this is almost like writing, in plain English. If we wrote out something like write this and then write this, it's essentially the same process. We're just telling a computer, write this thing first, and then once you've done writing this thing, write this thing. Okay, and that's all it is. And we don't have to stop at 2 instructions. We could have 3. We could say, my name is Ben or something. So now we got my first program. Hello, my name is Ben, and we could change the order of these. We could maybe move this one to be the first. Right. So now we get hello, as we see here. My first program, and then finally, my name is Ben. So hopefully that all makes sense so far. But this is how we give the computer instructions, is through this this code. And from this you could do a bunch of stuff. Maybe, for example, you could a good example of an activity you could try out if you're following along, is you could try print out some kind of interesting patterns or something. So, for example, here's like a kind of triangle pattern. So it looks a bit strange, but if I run this, I get like a weird chevron.
Christmas tree, right?
Yeah, Christmas tree. Yeah. And then you could take this, you could do it maybe 3 times or something. I know it's not a very good looking Christmas tree. They just look like diamonds. But you could do the trunk here maybe.
And this is ultimately, when we think back to, the first computers I started working on, back in the Ataris and things like that. This was the kind of the graphical output you could kind of get out of them. Is ASCII art, and ultimately behind that, there's a whole bunch of things printing stuff to the screen.
Yeah, and you could put whatever you want here. Like we just made. Well, I call it a Christmas tree. It doesn't really look like a Christmas tree, but you can
like a road sign in all
fairness. Yeah, but you can put whatever you can print out all kinds of patterns. So if you are following along, maybe try that. Maybe try I don't know, do a square, right? Or do like maybe a circle if you're feeling confident. There's all kinds of stuff you can do with it. But yeah, the next thing I want to talk about is something called comments, right?
We've just had a comment in the chat.
Okay.
From one of our colleagues, Phil. I'm assuming you're implying the last. My first computer was sometime in the 1700s. I'm not that old. So, let's think about something useful we can do with a print function, right? So, let's say you wanted to do a simple calculation. You wanted to use the editor as basically a calculator.
Yeah. So this is the cool thing about Python, is that so far we've just been writing out text, and you're probably thinking, well, that's not very useful. Clearly there must be some more going on. But the cool thing is that you can get Python to do calculations for you. So for example, you can say print 5 plus 5, right? And what Python will do is, instead of printing out the word hello, or in this case 5 plus 5, it's just going to print out the result of 5 plus 5. So if we run this, you might think that it might print out something interesting. It's going to print out just 10, right? So we could change this to 5 plus 10. What do we get here? Oh, we get 15. And we can do this with all kind of numbers. We can do things like we can.
So I think one of the interesting things with this is, before, when we were printing strings, it was just giving us exactly what was in that within those brackets, right? But now we're putting a calculation. It's still giving us exactly what's in those brackets. It's just finishing the calculation for us before it's outputting.
Yeah. So this is the thing, right? So you might ask, how does Python know to, for example, in here, it knows to look at this thing and go, oh, right, that's 5 plus 5. That's 10. And then it writes out 10. How does it know to print this out rather than literally what this is? Well, this is what these quotes are for. So if we have hello in quotes, it's going to print out hello, right? If we have, for example, let's put, I don't know, 10 plus 3 or something. Okay? If we do this, because there's quotes here, it's going to write out 10 plus 3. If you see
Ben, just so we can show that clearly, if you put another line in another print statement, do the 10 plus 3, but without the quotes.
Yeah. So here we have two things, right? So this one is writing this as text to the console, and this is it's evaluating this. So it's looking at this and going, oh, right, I need to perform this calculation. So if we run this, the first one here, this is this line. It's saying write out literally the text 10 plus 3. Whereas this one, we get 13 because there's no quotes here. It's treating this as a calculation. So Python's gonna go off, look at this, and then replace this with 13. And then it's gonna write it out. So that's what these quotes are for, really. If you want to literally print out something like this, you put the quotes. If you want it to perform a calculation, and it doesn't just have to be whole numbers, it could be something like this plus 1.3, and we'll get a result out like this. So it's a really useful thing.
So again, with the plus signs, so what would happen, for example, if we tried to add two strings together?
Yeah, so this is quite an interesting one, right? So here, just imagine this: we have a number here, okay, and we have another number here. Now we've got some text here, so we've got the word hello, right? And we run this, we get hello. What happens if instead of numbers we have 2 bits of text? So before what we had was 5 plus 5, and this thing here is a number, this thing here is a number. But what if these are like this? What does it do then? Because this is text, not a number. So what does Python do in this case? How does it add the word hello to another word there? Well, this is something called concatenation, right? So if let's run this and see what happens. We get 55, right? 5 and 5, and we get hello there, right? So we've got two things here. So let's look at this line in particular. On the left here, this is text, right? And this thing here on the right is text.
And that's denoted by those quotation marks. So whenever you're wrapping things in quotation marks, you're basically telling Python, you're telling the computer behind the code that this thing here, I want you to print it exactly as it is. This is a block of text.
Yeah, and so if you want you might see programmers, if you try search for this kind of stuff on the internet, you might see these being referred to as strings. So anything text related is called a string, and the reason it's called a string is because it's a string of characters, right? So a word is a string of characters, and that's why they're called strings. So if you hear me talking about strings, this is what I mean. I mean text, not numbers. So if we add these two things together, here we have a string, bit of text, and here we have a string. If we put a plus sign between these two, it's not going to add 5 and 5 and give us 10. It's going to basically join these two together like this and give us 55. If we put 310 on here and 50 here, it's going to give us this.
Or any combination of text and numbers. I mean, you could put hello 5, right?
Yeah, you could put hello plus 50, and then we get hello 50 because it knows this thing here is the text 50, not the number 50, if that makes sense. But yeah, if we did take out the quotes from something like this, and we were left with something like this, then it goes ahead because there's no quotes, and it's going to give us 360 instead. So the reason I was talking quite a lot about this is just that there's it can be very tricky at times when to wrap your head around what's a number and what is text. The first thing, whenever you teach somebody how to write this, the first thing they question is, what are these quotes? What do they mean? And that's what they mean. It means print out this text, not a...
Although there is a bit of annoyance in the chat that you're not writing hello world.
Yeah, that's true. I'll give you that. Yeah.
So this is the classic computer science first program.
Yeah,
whenever you're trying a new language, the first thing you figure out how to do is a basic hello world.
Yeah, exactly like this. So they call it like a hello world program. It is essentially just the minimum working example of just showing the word "hello world" into the console.
I'm not sure if I ever showed you, Ben, but I had a baby grow for my son that said
Yeah.
"Hello World" across the chest. It's fantastic.
That's great. Yeah, that's cool. But yeah, so that's why I was talking about these quotes and numbers.
So is there any difference between single and double quotes in Python then?
So yeah, that's a really good question. So we can use double quotes. So if we have "hello world" here, we get this. So let's try. These are double quotes, right? So they're this character. What happens if we put an apostrophe, single quotes, right? Does this work? Well, yeah, it does work, right? So you can use single quotes and double quotes. Just be aware that if you have a single quote here, there must be a single quote here as well. You can't mix and match these. You can't have one beginning with a double quote and one beginning with a ending with a single quote, because what's going to happen is, as you can probably see, there's a red line here, and it gives us this error. Well, let's have a look. It says EOL, end of line, while scanning string literal. So don't worry about what that means. It basically means that it expected a double quote and it found a single quote. So just make sure if it starts with a double quote, it has to end with a double quote. And if it starts with a single quote, in this case we've got a single quote and ending with a double quote, it has to end with a double quote as well. And you might be thinking as well, what's the point of that? Why would we do that? Well, the reason is if we have a double quote and we want to write I don't know, Ben's program, this is fine, right? Because there's a single quote and it's within double quotes. Okay, so if we run,
so it's not treating that quote as a symbol at that point, because at the moment you're not really putting quotes there. You're putting a symbol that means anything within this is a string, and this is something that we should be printing directly.
Yeah.
But by putting that within those, you're saying this is not a symbol, this is part of a string.
Yeah, exactly. And the easy way to test this, right, is, well, okay, what if we had double quotes here? What if we replace this with a single quote and replace this with a single quote? Well, suddenly everything goes wrong. The reason is that it thinks this is text, and then it can't find the beginning quote for this one, because as you can see, when I highlight it, it shows up these two. This thing here is text, whereas this has an ending quote, but it doesn't have one here.
So on the inverse of that, if you wanted to write something as a quote by a person, so say you wanted to print Chris says great, right? We'd have to do the inverse, wouldn't we?
Yeah, so here we've got the inverse. So we've got double quotes, right, inside single quotes. So everything's fine. This is, you don't really come across this until you start trying to do this, where you go, oh, I'll write out a quote, and then suddenly everything breaks, and you're like, oh God, what's going on there? I mean, I learned this the hard way when I started programming. I remember searching forums for literally all night trying to figure this out, and this is why, is because at this point, yeah, if we have single quotes, we can put double quotes inside, no bother, right? So if we run this, it says Chris says great with quote marks. But if we tried putting double quotes, suddenly everything goes wrong. So just be aware of that.
So there's been a question in the chat, Ben. What happens if you try to print, for example, speech marks and some quotations?
Right. Okay. So you mean both, essentially, like
yeah.
Okay. Yeah. So this is it's a good question, because this does come up. This does come up. Believe me. And you sat there going, how would I even begin to sort this out? So this
so
is where...
let's show an example of that. I think it's probably the
yeah. Okay. So let's do I don't know, Ben's program says hello or something. You can see now we're running into issues, because we can only use single quotes because this is double quotes. So how do we do this?
So basically, that first double quote at the beginning of hello has ended that string, right? So
yeah,
saying everything between there is a string, and then it doesn't know what to do with the bit afterwards. It assumes you've
Mm-hmm.
we call closed. As soon as you've closed those quotes, and you haven't, you've got quotes within quotes.
Yeah, exactly. So how do we sort this out? How do we tell Python that this quote here and this quote here are not the end of the string? It thinks the end of the string, like Chris said, is here, but we know the end of the string is here. So how do we tell Python that this quote and this quote is just part of the text? Well, you just put a backslash before these, and suddenly all your problems go away. This thing here is called an escape character. That's just the technical term for it, but that's how you do it. So let's run this. So now we've got a single quote, and we've got a double quote over here, which is great. So yeah, that's how you do it, and you can do the same as well. So if we flip this and put something like Ben's program says hello. So now we've got the inverse problem. So now we're starting with single quotes, and Python thinks this is the end of the string, but we need to tell Python that this is the end of the string, and this thing here between n and s, that's just part of the text. So how do we do that? We just put a backslash before it, and that way Python.
It's really important to know this, right? Because we talk about how versatile Python is. One of the things that we use Python for a lot, and we'll get to in a future episode, is data analysis. So if you've had a whole load of, say, survey data response, people might be typing characters that you don't want them to use. And actually, one of the general kind of rules of, I suppose, software development is if your users can find a way to break your software, they absolutely will. And you'll get all kinds of things typed into text boxes that you wouldn't expect. And we have to do this process of escaping. But, I mean, Python, it used to, it doesn't so much now, but used to power the back end of a load of social media platforms. And obviously people are typing all kinds of stuff there. But we also used it with, like I say, one of the things that Python is really powerful for is text analytics. So going through and evaluating large amounts of text. And again, if we're trying to print things from that, we might want to print quotes within quotes within quotes. But this is not just a problem with the Python Python programming language. We get this a lot in things like JavaScript and all kinds of stuff. It's a common issue. Sorry, Ben, over to you.
Yeah, so as Chris said, it crops up more than you'd expect. So just be aware of that, and that's why I wanted to cover these. But this thing, its technical term is an escape character, and there's a bunch of other escape characters which I won't really touch on.
At some point, we'll have to talk about how you manage to print a backslash when you want to.
Yeah, yeah.
But maybe another episode.
Yeah.
So what happens, Ben, if we try and print this without the quotes? So if we just put text in, no quotes.
Okay, so let's do that. So let's put in hello, right? So first off, I think it's being slow, but this should print out the word hello, right? Let's see if I can get this to work.
Tell you what, let me just remove that from the screen for a second while you just refresh.
Oh, okay, it's working. It's working. It was just very slow. So here we just have hello, right? What happens if we take out quotes and we just get hello? Well, something is clearly not working because we've got this red line and it says undefined name hello. If we run this, we can see that it says name hello is not defined. And I won't really touch on what that error means, but basically Python is trying to find something, and I won't talk about what that is, but it's trying to find something called hello, but it cannot find it. Okay, so without quotes, it goes off and it looks for something called hello, and
we'll talk about that, I think, next episode.
Yeah, so next episode we'll talk in what that is, right? And they turn out to be very useful things, and I'm quite excited to talk about it. But yeah, essentially, this Python looks at this, and because there's no quotes, it goes off and it tries to find something called hello. And this doesn't have to be; it could be anything. We could type in "my name is Ben," and something is clearly going wrong here. So essentially, if we want to print out the word Ben, we have to put it in quotes. like that. So
it's worth saying that anything you type into, the language only has so many ways that it interprets what you put into it. And in that case, it was treating the word, like say, as a reference to something else. So it was saying, hello, I need to print the thing called hello. And we'll talk about what those things are in the next episode, which is going to be all about variables. Giving the game away, it's a variable. But when we put things in quotes, we're saying this is a string. And again, numbers, we know that when we put numbers in, it will evaluate whatever that number is. And like I say, I think that evaluation is an important thing to get your head around. So if you put 5 plus 5 in there again, Ben.
Yep.
So that is 5 plus 5 is 10, right? So again, even when you print, it's always printing out exactly what is in those brackets. And that 5 plus 5 is exactly 10. It just does that evaluation before it prints it out. And if we wanted it to not do that evaluation, if we wanted to print it out as text, as 5 plus 5, we'd wrap it in quotes.
Yeah. So as Chris said, and we touched on this before, if you wanted to write out literally 5 plus 5, put it in quotes and you get 5 plus 5. If, however, 5 plus 5, put it without quotes, it'll go off and run this. It will compute this like a calculator and put 10 here and write out 10. We've touched on addition, but I haven't really talked about anything else. You can do all kinds here. So you can do subtraction. So let's do 5 minus 3 and we get 2. If you want to multiply something in Python, this is probably a bit where it gets, I wouldn't say confusing, but it's a bit different to how you'd normally see it in real life. Instead of a times like this with an X, you put an asterisk, the little star character. So you put that, and this thing means times. So times 5 by 3, right?
I would say you can always tell somebody who's been programming for a long period of their life, because when they write out multiplications, they do an asterisk instead of a time symbol. It just becomes more natural over time. So we've got we talked about concatenation, and can you just type up an example of concatenating 2 words?
Yeah. So we've got hello here, and we've got there, or to satisfy the people in the chat, let's do hello plus world. So hello concatenate this thing here on the left with this thing here on the right. If we run that, it glues them together, sticks them together, basically.
So in this case, we're using the plus symbol, not really to say add these 2 things, we're saying almost combine them. And again, this is the difference between strings and numbers. Sometimes the meaning of the symbol that you're using means something slightly different. Now, if we were to replace hello and world with 5 and 10, for example, not in quotes, it would print out 15.
Yeah, so let's try that. So as Chris said, 5 plus 10 without quotes, we get 15, because this is a number and this thing is a number. But if Python sees text and text, it goes, oh, right, cool. I know you need to join those 2 together, with concatenate them together.
So what happens then if we replace the 5? Mm-hmm. So if we remove the quotes from around 10.
Yep.
What happens when we run that?
Yeah, so this is, so we've talked about, if we have text on this side and we've had text on this side, we've also talked about numbers on this side and numbers on this side. So what happens if we run this? Well, we get an error because it says can only concatenate str, which is short for string, not int. Int just means integer, which is another word for a
whole number.
A whole number. To string. So it's basically saying that it can't glue these 2 together because it doesn't know whether to add them together because there's a number here, or whether to kind of concatenate them together because there's text here. All this means really is Python just got a little confused, and it's like, well, you've got a number here and you've got some text here. I don't know whether to.
Or it's telling you that you're confused.
Yeah.
I mean, this is an important thing when we're saying that symbol changes meaning based on what we put around it. When we have 2 numbers, plus means add them together, give us the output. When we've got 2 words, that plus symbol means concatenate. Now on this side, we've got a string, a word on the left, and a number on the right. and it's saying, I don't know what to do. I don't know if I add these. I don't know if I should concatenate them. What are you expecting of me? We're giving, and again, Ben said right at the beginning, computers are relatively, camera's just died. Computers are relatively stupid, right? They're just going to do what you tell them to. Now, at this point, it doesn't know what you're asking of it. So we have to make it slightly more clear, and we have to convert this into say, this is clearly what you do with this symbol.
Yeah. So for example, here, if we wanted to turn this thing 10 into an actual word that, is 10, we could put quotes here. That's one way of doing it. Another way to do this, and well, I won't get into why this is useful. You'll understand why it's useful next week when we talk about variables. Is to use this str thing, and we basically put whatever we had, which is 10, we put that in the brackets of this str thing here. And what this says is it says convert the stuff inside these set of brackets. So this 10, convert this into the word 10. So what's going to happen?
Well, the string 10.
Yeah, the string 10. And that's what str is short for, is string. So it's saying convert this thing into this thing, right? So we could put whatever we want in here. We could put 3.14 in there, right? And now look, we're saying glue 5 with the word generated from here. To make it a bit more clear, let's just do hello. Hello there. And maybe a colon. And you can see here, it has no problem, because what Python does is it sees this and it goes, okay, str, okay, I need to convert this thing into text. And that's what it does. It converts it into this for us. And then it does this. It goes, okay, cool. I've got some text here and I've got some text here. So that's all good. It knows what to do. It glues them together.
So if we go back to having the str, so we're going to talk about more of this in a future episode. We're going to end this stream quite soon. This is probably our last example now, actually. Remember when we were talking about that print statement and what it's doing when you put numbers in there? Whenever you kind of wrap things in those brackets, it's going to evaluate. It's going to give you what is in there. It's going to do some sort of task. And in there, what that little line of code is, that str brackets, it means whatever was in these brackets, evaluate it and turn it into a string. And fortunately, Python knows what to do when it has two strings either side of a plus. So now we're not dealing with this problem of having a different thing on one side and different thing on the other side. It now treats them both exactly the same, and we get the output.
Yeah, and that's entirely what this str thing is doing. Like Chris said, these things, they like Python. Whenever you see these brackets, basically, Python will take this and do something with it. So in this case, str means take this thing, and basically, you can kind of think of it as just putting quotes around it. Converting this thing into a string, and yeah. For example, one thing you could do is what happens if you try put in hello without quotes? Well, you'll get an error because again we have this thing of it doesn't know what to do with hello, so it does expect numbers basically.
Brilliant. So on that note, we'll end it for today. So thank you very much for joining us. Like I say, these are gonna get steadily more complicated as we go through. And next week we're going to talk all about variables, which again was what was causing that error earlier on. Really hope you've enjoyed the session. By all means, leave us some feedback in the comments, drop us an email. Let's say, my name is Chris, this is Ben. We're both from the University of Lincoln, and thank you very much for tuning in today.
Thanks, guys.